Next up, we would like to draw a Lewis structure for SOCl2 and show any lone pairs, non-zero formal charges, and if it has a hybrid, if it's a resonance hybrid, draw them. And so let's begin by counting our valence electrons as we usually do. We're going to have 6 plus 6 plus 2 by 7, and this would be SOCl2. And that's just going to be 12 plus 14, which is 26 electrons. Okay, and so we're going to place sulfur in the middle instead of oxygen because it's more electronegative. Okay, so to choose our central atom, it would be between sulfur and oxygen because they can make the most bonds. But oxygen is more electronegative than sulfur, and we like to place the negative charge on the oxygen. Adding more bonds, as we are about to, more bonds than the 2 is going to make the charge positive. And so we wouldn't like oxygen to be in the middle because it would have a positive charge instead of the preferred negative. And so let's go about adding our oxygen and our 2Cl and filling in everybody's octet. Okay. And so now we can count all of these electrons, and so we have 6 by 3 plus 2 by 3 plus 2, and that is going to be 18 plus 2 plus 6. And so we do have our intended, 18 plus 2 plus 6, our intended 26 electrons. But let's double check our formal charge to make sure everything is okay on that one. And so on oxygen, we are going to have 6 minus 1, so negative 1. On the sulfur, we are going to have 6 minus 3 minus 2, so positive 1. On chlorine, we are going to have 7 minus 6 minus 1. So 0. So we have negative 1 and positive 1. The net charge makes sense. These two would cancel to give a 0. But there is a way to lower these two. And we can do that by including a double bond here and seeing if that does anything about these two. And so let's have a double bond, which would make us fix these octets. Let's see if our valence electrons still make sense. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. And so we still have 2 electrons. But we see oxygen is quite happy right now. It has its 2 bonds and its 2 lone pairs. And so rather than mess that up by adding the 2 electrons back on the oxygen, and oxygen can't even have an expanded octet, let's put them on the sulfur. And so now our electrons are all good again. And so let's double check the formal charge. Now on the oxygen, we are going to have 6 minus 4 minus 2, giving us 0 as we'd like. On the sulfur, we are going to have 6 minus the 4 in bonding pairs minus the 2 in the lone pair, giving us 0 as we'd like. And the chlorine hasn't been changed at all. So both will be 7 minus 6 minus 1, giving us 0. So we've minimized the formal charge, the net charge is correct as it should be, and the valence electrons are all accounted for. So this is the correct structure. Yeah. And so there's only one equivalent structure if it has any resonances. Actually, and the resonance structure that it does have is instead what we drew before, where the 26 electrons are taken care of, but the formal charge is a bit different. And so for our resonance structures, we are going to have let's just redraw this. And this is it.